Okay, this is the mock exam that I posted in Google Classroom. So it says, in a time of extended drought, citizens in a small city in Southern California were required to restrict how often they ran water to their lawns. As a result, some of the trees in the city died to lack of water. A concerned citizen decides to take a sample in order to measure the number of dying trees. He uses a city map that divides the residential homes into several thousand blocks. He randomly selects 75 blocks. For each of these 75 blocks, he counts the number of dead trees on each block. Here's a histogram of his data along with summary statistics. Each bin on the histogram has a width of 2. First bin contains 0 and 1, the next contains 2 and 3, and so on. So this actually gave us a summary of statistics, so gives us a better picture of what is actually, the mean and median and all that. And then it's not always going to give you that. So, and then it gives you a histogram. So it says describe the distribution. So this is like literally chapter 1. We have to use CUS plus context. If you do not have context, then you're not going to get full credit. So the first thing I would do is start out with your context and say the distribution of number of dead trees per block is skewed right. That's what I would say. And then you've got your context in there. You don't have to say it in every sentence, but you need to start out. So I started my first sentence. The distribution for the number of dead trees per block is skewed right. Notice it's skewed right. So I've got my shape. We'll say this one's shape. With one block containing a large number of dead trees between 14 and 16. So that we're talking about that unusual feature, an outlier. Okay. Next, we'll do center. Well, it actually tells us the median. If it didn't tell us the median, we would have to count, how many, if we know this is a total of 75, we'd have to kind of count the bins. I doubt they'll give you that since it's this kind of test. I don't know if they could. So you'd have to, estimate the number and figure out the median from there, figure out the middle number. But it does tell us that, so we're going to say the median number of dead trees per block is 1. Now, just a reminder that since this distribution is skewed right, the best form of center is the median, because if it is symmetric, the mean is good, but this is not symmetric. It is skewed right. Now, I'm not saying that that's incorrect to use the mean number, but I'm just reminding you, okay? And notice that it's skewed right, so the mean is greater than the median, so we knew that. Follows the outlier. So I put the median number of dead trees per block as 1 tree, so I said the center, and the standard deviation of the distribution is 2.883 trees. Now, normally you wouldn't be able to tell the standard deviation based if it didn't have this. This is the standard error, okay? That is for like your sampling distributions. Don't use standard error. Use standard deviation. So, which is this number here. If you don't see that, or let's just say if that wasn't there, you would have to use something about the variability. And you would need to say something like the number of dead trees varies from 0 to 2 to 14 to 16, because you don't know exactly how many. So just if this was not here and you had to say something about the variability, then I would say the number of dead trees vary from 0 to 2 to 14 to 16 trees. Now, what I don't want you to say is from 0 to 16. Because you don't know for sure if there's any, at this point, if there's any that's 0. These could all be 1. We don't know because it's a histogram. And we don't know if this is 16 trees or not, because obviously this one's not anyways, it's not including 16. But that's what people want to do, and that's incorrect. So just remember on a histogram, if this was not here and you couldn't actually see the table of statistics, then you would need to state something on variability, and I think that's probably the best way to do it. So on a histogram, it would need to be an interval, because you don't know for sure. Okay, so next part, interpret the standard deviation. The standard deviation is the typical distance from the mean. We have to put that in context. So in context, the number of dead trees per block typically vary from the mean by about 2.883 trees, okay? So just remember, basically you're saying like each house or each block that they sampled typically varied by about this from the mean, okay? Next, it says name the sampling method used by the citizen to estimate the number of dead trees per each home. Describe why this method of random selecting blocks was more practical choice compared to the simple random sample of homes. Well, first of all, we have to do the sampling method. The sampling method was cluster. Why was it cluster? Because they selected a block and they sampled every single tree in that block. That means that was cluster. Remember, cluster breaks it up into parts. Like, for instance, if I did the lunchroom, I would break it up into like tables, and I would sample that. I'd maybe select 3 tables, and I would sample the entire table. Okay, so that's why it's cluster. Then you need to compare. Okay, why it's more practical than a simple random sample of homes, meaning just homes, you know, in a hat, and you just randomly select a home, and you'd have to go to that house. Okay, so I'm going to answer this question. Make sure when it says compare that you actually do that. So I made sure that I answered the question. The sampling method is cluster. So cluster sampling was used by the citizen to estimate the number of dead trees per home. This method is more practical than an SRS of homes because with cluster sampling, the citizen can select a block and sample all the trees in the homes on the block as opposed to driving around to individual homes. Cluster results in less driving, which is time, and gas money for the citizen. So you have to say something as opposed to going around each individual home. So it's asking you to compare, so you must compare. So the next question says, estimate the probability that a randomly selected block, just one block in the city, will have less than 6 dead trees. So, all right, these right here are less than 6. So all of this is less than 6. Well, to me, it's probably a little bit easier just to count, since it's 75 total, the ones that's greater than 6, and then just subtract from 75, if that makes sense. So I think this looks like it's maybe 1. And then this is, let's see, I don't know, maybe 2. Okay, and then it could have been 3. Let's see, 4, maybe, or 5. Let's say maybe that's 5. Let's say maybe this is 3. Maybe that looks a little bit, it's okay, it doesn't matter if it's just whatever you think, as long as it's close. So let's see, that's 5, 8, that's 9. That would be greater than 6 dead trees. So, I think I'm pretty tired. Sorry, y'all. It doesn't matter, but still, okay. So 5, 6, 7, 8. So I'm going to say 8, because I think that's probably twice that. Okay, so we'll say 8 trees is greater than 6. So if there's a total of 75, what is that, 67 that's less than 6? So, okay, it says the probability that less than 6 dead trees. So notice I just put a correct notation. We talked about using sentences, which is fine, but I think it will take up more time. And with this kind of test, with only 45 minutes, proper notation is probably the best way to go. The probability that less than 6 dead trees, selecting 1, is, let's say we said 8, right? So that's 67 out of 75, because there's 75 total. And I counted 8 that was greater than 6, so that means 67 of them. So it's easier to count 8 trees than it is 67 on your histogram. Okay, so it's your choice, but you want to go with whatever is the quickest. Now you can leave it like that, or you can do a decimal. So 67 divided by 75 is 0.893. So, and if you have something a little bit different than that, so if you counted like 68 out of 75, it's fine, as long as it's close. Okay? Okay, so again, just an approximation with that is fine. Okay, so next is, let's see, it says we will assume that each block is independent of the next, given that 19 of the city blocks had no dead trees. What's the estimated probability that if 4 city blocks were chosen, 4 city blocks were chosen, these blocks would have at least 1 dead tree. So I just want you to remember that if something asks you for at least 1, it's basically 1 minus the probability of none. Okay, so that's always the easiest, is just find the probability of none and then just do the complement of it. Okay, but they selected 4 city blocks, and none of them in all 4 of those would be what we would be finding, and then we'd do 1 minus that. Okay, so if we just selected 1, if we just had we had all of the blocks in a hat, and we selected 1 block, the probability of having no dead trees in that 1 block is 19 out of 75, which is 0.253. Okay, the problem is we want to know the probability if we selected 4 blocks and they were chosen, that at least 1 would have at least 1 dead tree. So what we're going to do is we're going to find the probability of selecting 4 and having no dead trees and do 1 minus that. Okay, so we're doing the probability of no dead trees in 4 of them. Okay, so we got to think about this. So we select 1, and the probability of having no dead trees is 0.253. Okay, we select another one. No dead trees. No dead trees. No dead trees. Okay, so that's the probability of finding no dead trees. So we just want to find the complement of that. So really it's 0.253 raised to the 4th power. So we got to find the complement of that. So that's 1 minus this, 0.995. So 1 minus 0.253 to the 4th power is really what we're doing. And that is 0.996. Okay, so the probability of at least 1 in 4 blocks is 0.996. Okay, you can also do that's basically a binomial CDF of at least 1. So you would do a binomial CDF and put in 0 and then do 1 minus that. Okay, so just remember that always, if it says at least 1, it's going to be 1 minus the probability of none of those happening. That's usually the easiest way to do it. Okay, so for further analysis, the concerned citizen is creating a 95% T confidence interval to estimate the average number of dead trees. Are the conditions satisfied for inference? Why or why not? Well, first of all, you've got to go through the conditions and you have to answer the question. Okay, so this is when we have to go through the conditions. So number 1 is randomly selected blocks, 75 blocks actually. 2, 10% condition. 75 is less than 10% of all the blocks, and it tells us that the population is several thousand blocks. Okay. 3, make sure that you put approximately normal instead of just normal. I did not do a good job of that, but I want to make sure that the reader knows that you don't think it's exactly normal. And you have to at least say, how do you know that it's approximately normal? Because 75 is greater than or equal to 30 by the central limit theorem. The central limit theorem applies to means, and this is talking about the average number of dead trees. Remember, if it was proportions, it's p times 1 minus p, the square root of p times 1 minus p, p times 1 minus p is greater than or equal to 10, and then this is for proportions, and then, np is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So that is for proportions only, just a side note in case you had one for proportions. That's how you state normality. I don't know what I was doing right there, but anyways, not means. Okay, so if it was proportions used central limit theorem, it's wrong. So proportions, means. Okay, that is a side note. This is not proportions, but okay. So let's see. Now, what is normal? Remember, like, what are we saying that is normal? We're basically saying the sampling distribution for the sample mean is approximately normal. So if we took many samples, okay, of 75, then the sampling distribution would be approximately normal. And why do we want to do this? Because we want to be able to use normal calculations. The next question is talking about the researchers were curious if different regions of the country differed in their use of a new popular social media app. The two independent random samples were taken, one sample from a city on the West Coast and another from the East Coast. College students aged 18 to 25 were asked if they use the app. Their responses are organized in the table. So on the A part it says, does there appear to be an association between the coast a student is from and whether or not they use the social media app? So the thing you want to do is you want to look at the students from the West Coast, what percentage of them use the app, and of the students from the East Coast, what percentage of them use the app. You do not want to use this total because obviously the sample size from the East Coast is larger than the West Coast, so there should be a larger number of or proportion for the total that use it from the East Coast, but that doesn't really tell us anything. So make sure that you use the correct probability. So what I'm going to do is I'm going to say the probability that they use the app given they are from the West Coast, and that would be how many people are from the West, or how many people that they sampled from the West Coast was 221, and then how many people use the app, and that is 123. So 123 divided by 221 is 0.557. And then we're going to do the probability that they use the app, given they're from the East Coast. So how many did they sample from the East Coast? They sampled 423. Notice this is a conditional probability. How many used the app of those 423 people? 270. Okay, so 270 divided by 423 is 0.638. Okay. So notice I said since 63.8% of East Coast students use the app and only 55.7% of West Coast students use the app, there does seem to be an association. East Coast students seem to be more likely to use it or use the app. So you need to make sure you answer the question. You need to back it up with statistics. The next question is, what's the probability that randomly selected student is from the West Coast given the student has used the social media app? So the conditional is, it says, given that they use the social media app. So probability they're from the West given they use the app. So we're only looking at people that use the app. So, okay, use the app, yes. How many use the app? 393. So that is the conditional. We're not looking at anybody else besides the people that use the app. So what's the probability they're from the West Coast? So how many are from the West Coast that use the app? 123. So 123. So let's see. 123 divided by 393.313. The next question is asking, it says the curious statistics student wants to test if the proportion of students who have used the app is greater on the East Coast than on the West Coast. Write the appropriate null and alternative hypotheses for this hypothesis test. The main thing I want you to do is make sure you write your parameter, because you're going to write the your ho and your ha, and you're not going to state your parameter. So make sure you state your parameter or it's not going to be fully correct. So I just stated my parameter. Notice I did not use p hat because it's the population. And make sure that when you're stating your parameter that you don't use past tense, because that means that refers, or that implies that you're talking about the sample and you're talking about just everybody. So I just notated, I mean, if you wanted to use like P1 and P2, that's fine too, but I used PE, which is true proportion of East Coast students who use the app, PW, true proportion of West Coast students who use the app. So your HO is always going to be that they're the same. The proportion of East Coast students who use the app is the same as your West Coast, and the student is suspicious that the app is greater, the proportion of students who use the app is greater on the East Coast. So that should be your HA. Now you can also do this. This is also an alternative. You can do PE minus PW equal to 0. Okay, and you can do this. PE minus PW is greater than 0. But I use this form, okay? But this is what that means, okay? So if there's no difference when you subtract them, they'll be 0. The next question says the p-value for the hypothesis test is 0.022. So we want to make sure we compare it to our alpha, make the decision, and then do your supporting evidence. So there is my solution. Y'all are usually pretty good about this. So since 0.022 is less than 0.85, we will reject the HO. We do have convincing evidence that the proportion of students who use the app is greater on the East Coast than the West Coast. So the next one says, in another study, college students on the East Coast were compared with 85 students in the Midwest. So I guess they're doing the same thing, trying to see if the East Coast is greater. P-value of 0.13 was found. However, there is a concern for type 2 error. Describe how a different sample size would decrease the likelihood of type 2 error. So the thing I do want you to remember is about power. Okay, and this is just a note that power is 1 minus your probability of a type 2 error. Okay, so obviously if we increase our power, okay, so we'll have, if we have a bigger power, then we'll have a less likelihood of getting a type 2 error. So then we got to think, well, why is that? There's several things that you can state, and I'm going to kind of write out what I think you would say and what I think would be acceptable. Okay, so with this in mind, I'm thinking that maybe you might be thinking power, and which is fine. I want you to know just kind of how I would probably say it. So it's just wanting you to tell about how describing how a different sample size would decrease the likelihood of type 2 error, okay? Remember type 2 error, hot hat, okay? What a type 2 error is. Type 2 is if the HA is true and you're wrong, okay? Meaning you failed to reject and you should have rejected it. Okay, so I put when increasing sample size, it gives a bigger picture of the population. So it gives a bigger picture of what's actually happening. Additionally, it gives us more power to reject a null hypothesis. A larger sample size also gives us a smaller standard error in the sampling distribution. So just think about it when you're doing, when you're doing the sampling, the standard deviation or your standard error, it would be P times 1 minus P divided by N. So if this is a larger number at the bottom, if you have a larger number at the bottom, that's a smaller number altogether. If you got a small number here, large here, this right here results in a really small number, meaning if it was like 1 over 100, that's a smaller number than if it's 1 over 10, okay? So your standard deviation or your standard error is going to be smaller also. So if you have less error, it's going to be easier to distinguish the differences.